Variables that are ordinal level of measurement have attributes or categories that are mutually exclusive, exhaustive, but also have a hierarchy. For example, if I asked how satisfied you are with the online program, the categories may be dissatisfied, somewhat satisfied, or satisfied. There is a hierarchy within the categories or attributes. While we can't do any mathematical equations, we can determine the mode, the most often response. Variables that are at an interval level of measurement have the same characteristics as the previous types of measurements. Mutually exclusive categories or attributes, exhaustive, and demonstrate a hierarchy. Additionally, this level of measurement shows equal distance between each attribute. Looking at the example on the PowerPoint slide, we see self-esteem scores, with equal distance between their categories or attributes, such as 10 to 20, 20 to 30, and so on. However, there is no absolute zero. At this level, we can start performing mathematical equations unlike the previous level of measurements. Variables that have ratio level of measurement have absolute zero, such as height, weight, age, and income. These variables have the same characteristics of preceding levels of measurement. However, because we have an absolute zero, we can perform more complicated statistical techniques. Sometimes, researchers will use or interpret interval and ratio level variables at the same time. We always strive to use a ratio level variable, if possible, as we can use mathematical equations such as the mean, mode, median, standard deviation, variance, and other more complex mathematical formulas, whereas nominal and ordinal are limited to percentage or proportion and frequency of the values of each category. Now, sometimes we can take a ratio level variable and change it or recode it into a nominal or ordinal level variable. However, we cannot change nominal or ordinal level variables into interval or ratio variables. This is another reason why we strive to use interval or ratio level variables. Sometimes we want to change a ratio level variable, such as depression scores, into a dichotomous variable or nominal variable. Yes, the individual is clinically depressed, or no, the individual is not depressed. After reading the instructions of the interpretation of a depression instrument, measurement, or tool, we would determine the score that indicates the point where the individual is determined to be depressed. Let's say that a depression scale has possible scores of 10 to 80, and the score that indicates clinical depression is 50. Scores ranging between 50 to 80 would be considered yes, clinical depression is evident, and scores 49 or below would be considered no clinical depression present. We may use SPSS to recode our ratio or interval variables into nominal or discrete variables. When we have a variable that has a small number of distinct categories, we call these variables discrete variables. For example, gender is a variable with the categories of male or female. When we choose the sample of our study, it is chosen from a population or the total set of individuals or total units of analysis that we are interested in. For several reasons, researchers may not be able to use the whole population that they are interested in, and hence they choose a sample from the population or a small subset of the population. When selecting a sample, we can use probability sampling, where we use methods of randomization to select the units of analysis into our sample. As a result of random selection, the characteristics of the sample are similar to those of the population, and therefore the findings from your sample may be generalized to your population. However, due to a low population size or inability to randomly select the sample, researchers may select their sample using non-probability sampling methods, such as purposive, convenience, or snowball. In developing our research design, we may choose to have one group, or we can use two or more groups. When we use two or more groups to compare the DV, we may want to randomly assign our sample or study participants to the groups. If we use random assignment, our groups are considered equivalent in that groups will have the same characteristics, and therefore the extraneous factors of group characteristics cannot be attributed to the changes in the DV. Do not confuse random selection with random assignment. When we are unable to randomly assign our sample participants to a design that uses two or more groups, we refer to this design as a quasi-experimental design. We often see this design used at agencies when they are comparing those engaged in an agency-sponsored intervention and those who may be on a wait list for the intervention. A single system design examines baseline and intervention scores or behaviors of an individual. We'll talk more about this type of design in greater depth later in the semester. In every research design, certain biases exist that may influence our outcomes. For example, we can have selection bias when characteristics of the sample will influence the DV or outcome variable. Historical events may impact the DV. For example, if we measure self-esteem before and after a cognitive behavioral therapy for domestic violence survivors, a historical factor may be the death of a loved one during the intervention. The bias of maturation is a major consideration when we are using pre- and post measures. For example, when we examine the reading levels of children before and after an intensive reading program, we must consider the bias of psychological and physiological maturation or growth that may attribute to the changes in the reading abilities and not the intervention. When we design studies that have a pre-test or post-test or several post-tests, we have to consider the distance and time between the tests or observations, as sample participants may remember how they answered on the previous observation, albeit the pre-test or another post-test. Unfortunately, a true response will not be obtained if the respondent responds using the previous answers. Instrument bias refers to the process whereby the instrument or measurement or tool can actually change the experiment or study. The questions asked of an instrument can actually change how participants think or respond to questions, instead of just responding to the question. The bias of regression toward the mean refers to the common occurrence of scores that may be extreme returning toward the mean score in subsequent observation periods. Individuals with outlying scores will normally have subsequent test scores that are closer towards the mean. Hence, outliers or those with outlying scores must be evaluated for bias in changing the outcomes. Another bias that we cannot control in our studies is attrition when participants decide to leave the study, or mortality when our participants may die during the study. For example, Zvi Gellis, a professor at UPennsylvania, and Dr. Bonnie Keneally studied the impact of a telehealth intervention on depression scores in homebound elders with a history of congestive heart failure and/or chronic obstructive pulmonary disease. They used a randomly assigned two-group pre-test, post-test design. Unfortunately, several of their willing participants died between the pre-test and post-test. I hope you found this PowerPoint to be a helpful review of research methodology. If you have any questions, please reread your textbook. If you continue to have any questions, please contact your professor.